Hi, my name is Kristen Lavery. I'm the Assistant Director for the Leonard Gelfand Center for Service Learning and Outreach at Carnegie Mellon University. And today I have with me an undergraduate student researcher.
Hi, I'm Charlotte Andreasen. I go by Charlie. I'm 20 years old. I'm from Sheboygan, Wisconsin, and I'm a rising junior studying mechanical engineering and engineering and public policy at CMU.
Looking back, what or who was your greatest influence? And then how did this spark your interest in your current major?
So I was really fortunate to have a lot of really great science and tech ed teachers throughout high school who all influenced me to end up in mechanical engineering. But I think the main two people who influenced me were Mrs. Pills, my 7th grade English teacher, who I did this composting project with, and then my 8th grade science teacher, Mrs. Bloom, who was really the person who got me into science in the first place. She was just really enthusiastic about teaching science and got me excited about it and asking questions and wanting to learn more about everything that we did in that class. And before that year, I'd really seen science just as sort of memorizing different facts. And she was the first person who really got me to see science as a tool for just explaining how the world works.
What are you currently researching in Dr. Taylor's lab?
So I'm working on designing and testing a nanoscale shear stress sensor using DNA origami.
What does that mean for us lay people out there?
So DNA origami is a newer field where we build things out of DNA. So what we do is we'll take one long single strand, about 7,000 bases long, and then design shorter sequences, or staple strands, that will bind to different sections of the scaffold, and that will fold it together. So by designing a whole bunch of these different staple strands, we can pretty much make whatever we want out of DNA. I'm working on designing a shear stress sensor, which means we would take these DNA structures and attach them to a surface and then have fluid flow over the top, and potentially we'll be able to determine what the shear stress exerted by the fluid is on the wall.
And what applications could this potentially have?
When platelets are exposed to high shear stress environments, they become a lot more likely to clot, and high shear stress in blood vessels can lead to atherosclerosis, and abnormal shear stresses on the heart during formation in babies and stuff can lead to heart deformations. So essentially this could be used as a diagnostic tool for risk of heart deformation, atherosclerosis, or heart attack or stroke.
What equipment do you use in Dr. Taylor's lab?
All sorts of stuff. So first we start with our CAD Nano software, which is just what we use to design the structures. It's basically just a CAD product for DNA. So we use that to design the structures and then order the sequences and then do a lot of pipetting to combine the sequences that we want, and then use the annealer to form the structures. So the annealer basically just holds constant temperatures at set times, so you can set up whatever temperature ramp you want to form a specific structure. And then we use electrophoresis setup to test the formation of the structures, and then we can look at them under the microscope, and we use TIRF, which is total internal reflection fluorescence microscopy, to look at the fluorophores that we put on these structures.
How do you spend a typical day in the lab? What are your responsibilities?
So it really changes a lot day to day. So sometimes it's designing the actual structures and ordering sequences. Some days will be actually just a lot of pipetting to build the structures. Some days will be testing formation or testing different environmental conditions for when we put these structures in flow cells. Some days are just a lot of reading to try and figure out why things aren't working or how we can improve what we're doing, and figuring out what other labs have done that worked to improve how we do things. So it changes a lot day to day, which is kind of nice, so it never gets boring.
What's the most important skill to have for this research position?
Probably just patience and perseverance, because everything goes wrong. Nothing really works the first time, and just, keeping your eye on that goal and trying new things and just to keep going.
So then what motivates you to continue learning?
I've been fortunate to find research and majors that are just really interesting, and so because I'm passionate about them, I just enjoy learning more.
Right now, you're a rising junior, so you have a lot of time, a whole lifetime, to figure out what you really want to do. But what potential careers seem really interesting to you at this point?
So at this point, I'm not really sure, and I'm not ready to really narrow it down yet, so I'm just kind of keeping my options open. But I do know that I want to keep doing what I'm doing now, which is just working on fun and interesting projects with fun and interesting people.
If you could go back and talk to yourself as a middle school student today about the years to come, what advice would you offer?
So I used to get pretty stressed out by change and trying new things just because I didn't really know how things would work out. And I guess it didn't really stop me from doing new things, but I would just go back and tell myself to chill out a little bit about it.
Finally, what advice would you offer to current middle and high school students?
I would just say that they should do things that they enjoy. Instead of focusing on resume builders or things that they should do, I think doing things that they're passionate about will really lead them to the careers that they'll end up enjoying.
Thank you, Charlie, for coming in today to spend some time with us. And I hope you all enjoyed this episode of the LGC STEM Career Explorations. And please be sure to check out the 360 Lab Tour.